Okay, so we are going to talk about rational numbers. I'm also going to solve some of the questions from the tutorial sheet, some of the most common questions that they like bringing on tests and final exams. Okay, so basically, rational numbers are numbers that can be expressed as fractions. Any number that can be expressed as a fraction is a rational number. As long as it can be expressed in this form, a over b, it is a rational number. For example, 1 over 2 is a rational number. 2 over 4 is a rational number. 3 over 9 is a rational number. So as long as it can be expressed in this format, it is a rational number. And the number that is here as a denominator shouldn't be the number that can be divided into the one that is above. For instance, if it was like 4 over 2, 4 is divisible by 2, right? So this is not a rational number unless it is something that when simplified further, it is going to remain in fractions. Okay, so now these rational numbers, when they are in fraction form, they can be further simplified into a number having decimals. For instance, 1 over 2 can further be simplified to 0.5 to 0.5. Yeah, so when you can you can either represent the number in this format or in this format. So now one of the most common questions which they like asking is they'll tell you to convert from this format to this format. They might give you maybe a very complex number, like as in complicated number, then they want you to reverse it to this form, the fraction form. So one thing you need to know is that rational numbers can be categorized into two. That is, if we are leaving them into decimal form. So let's say categories. So the first category is terminating numbers. We have terminating numbers, terminating decimal numbers, terminating decimals. So this category consists of numbers that are terminating, meaning the numbers that are ending. To terminate means to end something. Yeah, so when the decimal numbers are terminating, it means they are ending. For instance, we can have 0.5. This is just ending right here. It is not going any further to the infinity. No. And then none of the numbers are repeating themselves. So terminating decimals, they don't go to the infinity, and they are not. It does not consist numbers that are repeating each other. Example of numbers that are repeating each other, maybe 0.22. These numbers that are coming after a decimal point, they are repeating themselves. As you can see, we have 2, 2, 2. So this is what makes them to be under this category of terminating decimals. They are not going to the infinity. They are terminating somewhere. Okay, so the second category is repeating decimals. we have repeating decimals. Repeating decimals. Sorry. So we have fractional numbers that has repeating decimals. So now what this means that the numbers that are coming after a decimal point are repeating each other, and they are going to the infinity. They are repeating each other to the infinity. For instance, we have 0.555 dot dot meaning to the infinity. I'm pretty sure you have observed this on your calculator sometimes when you do some sort of calculations, then you get an answer which is in this format, where the numbers that are coming after a decimal point are repeating each other. Another example, so like in our scenario we have 555, so the number 5 is repeating itself. It can just be a single number. Sometimes they can be 2 or 3 or even more. For instance, maybe let's say 0.26. So now, as you can see, so the number 26 is repeating itself. So now, it's going to the infinity. So now there is a certain way of representing this. Instead of showing it all, or even showing these 3 dots, which represents the infinity, you can simply, let's say, like for instance, this number here, as you can see, 5 is repeating itself. So you can simply write it like this: 0 point. So this is equal to this represents this 0.555 to the infinity. And then even this one, 0.26, you can just you can simply represent it like this: 0.26. You even draw a straight line above. The moment you just draw a straight line above like this, it means that this number that is under the straight, that is under this line, it is repeating itself. So it's not always necessarily that the numbers that are coming immediately after a point are the ones that repeat itself. Sometimes you might be in this scenario, maybe 0.677. So like in our scenario, the numbers that are repeating themselves are these. So 77. So 7 is repeating itself after 6. So meaning you can also represent this like this, in this format: 0.67. Okay, so now let us now try to solve some of the questions from the tutorial sheet. So now, before we start solving any question, let me just remind you of a certain concept that we used to use when we were back in high school. I'm pretty sure you also learned that. So let's see. So for instance, you've been given 0.5. I'm pretty sure you are well aware that if you, as you can see, this this is in decimal form, right? So there are some scenarios where maybe we were taught to remove it from this form to a whole number. If you want to take this to a whole number, like a number without a decimal, we used to multiply it by 10. You see, we used to multiply it by 10. In case maybe we have a number like this, 0.6, 66 would multiply it by 100. So if we multiply by 10, then it will be 5. If we multiply by 0. If we multiply this by 100, we used to have 66. So this is a very important concept on this topic. If you want this topic to make sense to you, you need to know this. We're going to be referring to this concept. Okay, so let us try to solve some of the questions from the tutorial sheet, as you can see on the screen. So let's go ahead and solve the first question. So we are converting 0.33. So this simply means that 33 is repeating itself. So the first step is, you remember this concept. If we want to take a number that is in decimal form to a whole number, so now here our first aim will be to convert this number that is in decimal form to a whole number. So how do you do that? So the key is you are going to see how many numbers are in front of this dot. 1, 2. So you are going to multiply with a 1 having 2 zeros. If there were 3 numbers after a decimal, we would have multiplied by 1000. Yes, that's what we did. As you can see, 0.5. After point there is just one number, so we multiply with 10. As you can see, 10 has got only 1 0, right? This 1 0 is going to remove this 5 and take it in front. That's the logic behind these calculations. Same applies here. We had 2 numbers after a decimal. We had to multiply with 100 because these 2 zeros are going to eliminate these 2 numbers that are after this decimal point. So same here. We are going to convert this. We are going to multiply with a number that is going to convert this number to a whole number. So that number is going to be 100. So first you have to say you can use any value, but I'm going to use x. Let x be equal to the number that we've been given. We've been given 0.33. Okay, so remember I said first you have to multiply with a number that is going to take this to a whole number without any decimals. So now after that you are then going to multiply with a number that is going to, let's assume that there is another number in front E. There is a number in front E. So now if there was a number in front E, we would have multiplied. That is after we do that. After we multiply with the one that is going to convert this whole thing to a whole number. That is after we multiply by 100. So suppose maybe we had a number in front here. We would have now multiplied with a number that is going to take this number here in front. When we're multiplying for the second time, we don't consider the terminating numbers. We only consider the number that is in front of the terminating number. Okay, don't worry, I'll give you an example that is involving that. Yeah, so but if there is no number in front of the terminating number, you simply multiply with 1, because there is no number that you are taking that you want to remove from the decimals. So meaning that you won't need to multiply with any number having a zero. So okay, so basically if there is no number in front of the terminating number, you simply multiply with 1. You simply multiply with 1. So I'm going to say multi. So I'm going to say multiply with 1 and multiply with 1 and okay, let me okay 1 and 100. So at first I said we begin by multiplying with the one that is going to remove these numbers that are behind the decimal point, right? So at first we are going to multiply with 100 throughout, which is going to give us 100x. If we multiply this by 100, it is going to give us 83.33. And then if we multiply this throughout, it is going to give us the same value, right? So here we are going to have we're just going to write the same value, 0.33 like this, and then we now subtract. We're now going to subtract. This is going to give us 99x, which is equal to, if we subtract this from this, so if we subtract this from this, we're still going to remain with 33, right? These are going to cancel, and then we're now going to make x the subject of the formula, meaning we are going to divide through by 99. So we are going to have 33 divided by 99, right? So if you want, you can end A. If it is very complex, you'll still be marked. But if you can manage to maybe divide through by a common factor, you can go ahead. So for instance, let's divide through by 3. Let's say 3a, 3a. That's going to give us 1. So I think we can just end A. 11/33. So this is our final answer. Okay, so let me just solve the last two questions, since these others are similar. Your question 2, 3, and 4 are just similar to the one that I've just solved. So let me solve question 5 and 6. Question 5 and 6. Okay, so question 5. So sometimes they might not show you that that the numbers are terminating using that sign, that straight line that we draw above. They will just represent them in their raw form like this. So it is you to notice that 17 is repeating. So you are going to write in another form, in another form of repeating numbers. So we are going to write like this, in this form. This means that 17 is repeating itself. And then we're now going to apply the same concept. So initially we are going to multiply. As you can see, there are two numbers after a dot. So meaning at first we're going to multiply with 100, because 100 is the only number that has got two zeros, meaning if we multiply this by 100, we are going to get rid of these numbers that are coming after a decimal point. Okay, so, and then since there is no number in front here, we're just going to multiply by 1. So we're going to say let, this time let's use p. You can use any value. So p is equal to 1.7, and then we say we now multiply with 101. So 100 when multiplied throughout this statement is going to give us 100p is equal to 100 times 1.17. It is going to give us 117 point, the number that is repeating itself. Don't forget to include the number that is repeating itself, always include it. And we will multiply through with 1, so p is going to come back. So 1 times 1.17 here is also going to come back. Like this. And then now we're going to subtract. Now going to subtract, this is going to give us 99p is equal to 116 when we subtract this from this. So we're going to write, remember these are going to cancel each other, so we're going to remain with 116, and then we're going to divide by 99. We make p the subject. So now p is equal to 116 over 99. If you can simplify this further, you can go ahead. If you can't, you can just end here. You will still get a mark. So this is our final answer. If you want, you can confirm using a calculator. It's going to get you back to this number here. Okay, so let's go to question 6. Question 6. So question 6. Okay, so this one is quite different. As you can see, there is a number in front of the repeating number. So 90 is what is repeating, right? It is repeating itself. So step 1, we're going to say maybe let's use x this time, and then is equal to this number 2.590, which is repeating itself. So now, as you can see, how many numbers are in front of the decimal point? There are 3 numbers in front of the decimal point. So since there are 3 numbers in front of the decimal point, you are going to multiply with a number that has 3 zeros, so that it can eliminate these 3 numbers. And which number is that? That number is 1000. So at first we are going to multiply with 1000, and then secondly, since now there is a number in front here, so now this time our aim won't be to eliminate all these numbers. Our aim will be to only eliminate the number in front of the repeating number. If there were 2 numbers, our aim would have been to eliminate the 2 numbers in front of the repeating number. So in our case, how many numbers are in front of the repeating number? There is only one number, which is 5. So our goal will be to eliminate only one number. Which is that number can we multiply with to eliminate this 5? That number is going to be 10. If there was like 55, meaning our goal would have been to eliminate two numbers. So instead of multiplying by 10, we would have multiplied with 100. Yeah, 100. So now let's multiply. Okay, so let's go ahead. We say we multiply 1000, and then secondly we're going to multiply with a 10 to eliminate this 5 here. So now let's multiply. So now let us multiply. Okay, let us go ahead. So we're going to say 1000 times x also times this number. We multiply throughout. We are going to have 1000x. No, oh sorry. So when you multiply, there won't be any point A. It is going to eliminate. It is going to get rid of these numbers. The decimal point is going to be eliminated. So we're going to have 2590.90. Don't forget to include this. And then now we multiply through by 10. So it's going to give us 10x is equal to. So this time we only want to eliminate this 5, not the 90. So only the 5 is going to come in front here. We're only getting rid of the 5 so that it can go in front. Yes, that's how it is. If you multiply by 10, meaning since 10 has only 1 0, the first number is going to be eliminated from being after a decimal point. If you multiply by 100, meaning since 100 has got 2 zeros, meaning the first and the second are going to come in front of the decimal point. Yes, so since you won't be using a calculator, this is how you should master it, so that you don't get confused. If you multiply with 10,000, meaning that you want to get rid of the 4 numbers that are in front. For instance, if we had something like 2, maybe 5, 6, 8, 2, 5, 6, 8, then we also had 7, 7, 2 as a repeating number. So at first you are supposed to count 1, 2, 3, 4, 5, 6. So so at first we would have multiplied with the number having 6 zeros. So we would have at first multiplied with 1, 2, 3, 5, 6, 1 million. So at first you were supposed to multiply, we would have multiplied with 1 million to eliminate these whole numbers from being after a decimal point. And then after that, then now we target these numbers that are in front of the repeating number. So secondly, we would have multiplied now to eliminate this. We would have multiplied with 1000. 3 zeros to eliminate the first 3 numbers, 6 zeros to eliminate the 6 digits. Okay, so would have been subtracted 1 million minus 1000. So that is the key. This is the method that I had to create for myself, because I wasn't understanding any explanations from the lecturers and tutors, so I had to form my own way of solving these kind of questions. Since you won't be using a calculator, you have to use your head. Yeah. So now you are going to multiply with 10 to eliminate this 5. So now it is going to be 25.90. then we are going to subtract. So 1000 minus, we are going to subtract 1000 minus 10. This is going to give us 990 x 990x. Then we are going to subtract now 2590 minus 25. So this will give us 2565. Then we divide through by 990. Okay, so they cancel. We're now going to have 2565,990. So if you can't simplify this further, you can just end here. This is our final answer. So this is how we handle these questions. So this is, I think, the most simplest approach, and also a reasonable explanation. You don't need to master anything. You just need to be saying, first you multiply with a number that is going to eliminate the numbers that are in front of the decimal point. Then secondly, you are going to now multiply with a number that will eliminate this number in front of the repeating number. If there is no repeating number, just multiply with 1.